Welcome to this Mathcast episode. Today we're going to be looking at probabilities and complements. I want to quickly remind you of the complement law. The complement law says that if you take the probability of an event A and add to it the probability of that event's complement, what you get is 1. Now, it's all well and good to remember the law as it looks now, but really there's two other ways that you need to be responsible for it, and that is simply by rearranging the elements in the formula. So not only does the formula say the first thing, but it also says each of these as well. And depending on the situation, it'll be good to use any one of these three rules. Let's set up a small example here. For this example, I'm going to suppose that there's 5 each of freshmen, sophomores, juniors, and seniors on Student Senate. And I'm going to suppose that 3 are chosen for a subcommittee. Let's say to plan homecoming. 3 are chosen for homecoming committee. The question that I want to ask is, what is the probability that there's at least one freshman? That's chosen. Now, the key word here, as you've probably noticed in class when we've looked at some of these, is the word at least one. And so just a quick rundown is, if you're looking at the event at least one freshman, or at least one anything, then the complement of that event is no freshmen. Now, because of the complement law, I'm going to show you 2 different ways that we could try and do this problem. One involving the use of the complement and one not involving the use of the complement. And I leave it up to you to sort of decide which is easier, although I'm pretty sure after you see me do the problem, you'll have a good idea of which way it is that you're supposed to be doing this. So I'll start off here by describing method number 1. And method number 1 does not use the complement. Alright, if we were asked to do the problem this way, there's a couple of things that we would need to start off by doing. The first is we would need to figure out the sample space. The sample space for this particular problem is a function of the fact that we're choosing... Oh, I guess I've left out that information. We're actually choosing a Oh, never mind. I didn't. We're choosing a 3-member subcommittee. So the sample space here is a function of the number of people that we're picking. We can pick, out of the 20 students, any 3 we want to be on the committee. There's no restrictions there. So it doesn't matter the order in which they're chosen either. So C23 is sort of the obvious choice here. And that's 1,140 committees that are possible. So if I was wanting to do this, there's a lot of different committees I could potentially put together. Now, out of those, I need to choose specifically the number of ways in which A can occur. So the number of ways that A occurs. Now this is a little bit more difficult to count. If I just try to straightforward count this, then I need to consider three things. If A is going to occur, then it's going to occur in one of three ways. Either you choose exactly one freshman, or you choose exactly two freshmen, or you choose exactly three freshmen. This is why this is a little bit more difficult, because there's three different ways in which the event A could be fulfilled. If we're looking at choosing exactly one freshman, then that is C5-1 chooses the freshman, and C15-2 chooses the other two members of the committee. So let me make that a little bit more clear. Here this 5 is the 5 freshmen, and we're choosing 1, and the 15 here are the other students, and out of the other students we would need to choose 2 because the committee needs to have 3 things in it. If I'm doing exactly 2 freshmen, then it would be C5-2 times C15-1. I need to choose 1 left over. And then exactly 3 would be C5-3 times C15-0. Alright. Now the question is, what do I do with these? Well, if you remember one of our earlier podcasts, we said that anytime you've described all the events or all the pieces of your event of interest, you need to add them up. So if I was to take each of these and add them up, you do this, then plus this, that'll give you a total of 685 committees. And each of those committees has at least one freshman because they have exactly 1, 2, or 3. Well, the probability then of A in this case is that 685 out of the sample space size, which is 1140. And then if we reduce that, we get 137 out of 228. Now, if I've done the problem correctly, when I go and try to do this second method, I should get the same answer. So I'm looking for 137 out of 228. The second method is going to be with the complement. So I'm going to use the complement law to my advantage here. So if I'm talking about complement and I just tried to calculate the number of ways that A occurs, the complement of A occurring is no freshman. So this is what I'm looking at here is a complement. So how many ways for A not to occur are there? Well, no freshman would be very easy to calculate. All that means is I'm picking 0 out of the group of 5 freshmen, and I'm picking 3 from the other. If you multiply those out, you should get 455. And so there are, the probability of a complement is 455 out of 1140. Still using the fact that the sample space is 1140 committees up here. However, that's not the answer, right? The answer is for A, I've chosen instead to calculate a complement. So if I want to get the actual answer, I need to calculate the probability of A using the fact that it's 1 minus the complement. So what I'm doing is I'm using this form of the complement law. In this case, probability of A complement is 455 out of 1140, and if you subtract those two, you get 685 out of 1140, which is the exact same thing we got here, and so it also reduces to 137 out of 228. Either way you do the problem, you're going to come up with the same answer, although I think, as you can see, the work is much more streamlined and in some ways a lot easier using the complement to your advantage there. So I want you to remember this keyword, at least one, and understand that when that's in the problem, you're probably going to want to refer to the complement law to finish it out. Thank you for watching.